Hi everyone, we'll be waiting 2 to 3 minutes before starting the webinar, just simply to accommodate for the rest of the attendees who are in the middle of connecting. Welcome everyone. Thanks for joining us and thanks for being part of our community. My name is Valan Kolika and I'll be your host for today. Just a few reminders before we start. If you have issues viewing the stream at any time during the presentation and are using the web browser version of Teams, please refresh your browser. If you're using the desktop app of Teams, please exit and rejoin. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security-webinars. Closed captions in several languages are available during the live broadcast, and you can enable them by clicking on the CC button located at the lower right corner of your screen. Please feel free to ask questions at any time by typing them in the live event Q&A window, simply by clicking on the Ask a Question button. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you enter it. We often get many questions on these webinars, and we will do our best to respond to all of them in real time. In the event if the answer was not provided, or if you may have additional questions post this event, please don't hesitate to raise them on our Azure Network Security forum at aka.ms/Azure Network Security community. If you're listening to this after the fact as a recording, that's also a great place to ask a question. Now, we love to hear your feedback on how we can improve these webinars. We can do so at aka.ms/security webinar feedback. And by the way, all the links that I'm announcing have been already shared with you on the chat or the live event Q&A window. I would also like to invite you to join our public community by visiting aka.ms/security community. Now, that's the best way to ensure you don't miss any future webinar or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, which you can sign up at aka.ms/securityprp. You can request features, give feedback, review our product roadmaps, register for events, or just simply join webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. In today's session, Anthony Roman will go over the content inspection using TLS termination with Azure Firewall Premium. Anthony is a senior PM manager who leads the network security GTP team. And without further ado, I will turn it over to him. Anthony, the floor is yours.
Thank you, Valen, and thanks everybody for attending this morning. We have a lot of content to get through, so I'm going to jump right in after just a very brief introduction. I think Valen said everything you need to know. I'm Anthony. I work within Microsoft Security Engineering. My team helps customers deploy and remove blockers from Azure Network Security deployments. We primarily focus on Azure Firewall, DDoS protection, and web application firewall. And today, what we're going to focus on is some new features introduced with Azure Firewall Premium. Particularly, we're going to concentrate all on TLS inspection, how to set it up, what we can do with it, why you might use it, and we'll go into quite a bit of demo about, just putting everything together. The slides are going to be mostly conceptual. You won't see that many portal screenshots. I'm going to leave the portal activity to live demo as long as the demo gods cooperate. So I want to thank also Ashish Kapila from my team who helped put together some of this presentation in the demo environment. He couldn't be here to present, but just wanted to give him credit. So moving into the actual content, what we're going to cover today is I'll take you through a brief overview of what Firewall Premium is, some of the new capabilities that it has, and then we'll dive into the specific feature that we're talking about today, which is TLS inspection. In order to explain TLS inspection properly, we'll go through two main pieces of it, which are going to be, and the actual setting up TLS inspection on firewall is a pretty easy thing to do. It's just a few clicks in the Azure portal, which I'll take you through. But a lot of the work that's involved in TLS inspection setup for Azure Firewall is the prerequisites and the requirements before you even get started. So we're going to spend a lot of time on provisioning certificates and managing those certificates in your environment in order to establish trust. And then finally, we'll close out with a demo to bring everything together, and I'll cover as much as I can in that demo with the time allotted. Okay, starting off with Azure Firewall Premium. For those of you that aren't initiated with Azure Firewall Standard, the current offering today, and Preview, Premium, by the way, is in private preview or public preview now, and so everybody attending this webinar is able to just provision one in the Azure portal. While it's in public preview, it's a discounted price, so I think it's a perfect time to go test it out. Starting with just Azure Firewall, we've done webinars in the past. If you want to get a deep understanding of Azure Firewall, the standard offering, go and like Valen said, there's links to all the video recordings of our previous webinars, and there have been a couple of good webinars about just Azure Firewall, how it works, what it does. But I'll give you a 1-minute overview. Azure Firewall is a cloud-native firewall. Think of it as a PaaS service that lives within an IaaS environment. In the diagram on the right side of your screen, you can see Azure Firewall is depicted as living in a central VNet in a hub and spoke model. Azure Firewall sits inside its own subnet, but it is beyond it sitting within your virtual networks that you manage. Azure Firewall is the bits and pieces behind the scenes are all managed by Azure, and so it is a PaaS service. It auto scales based on traffic volume and load on the VMs that work behind the scenes. And so think of it as a replacement or a potential replacement for what you might already do with virtual appliances within Azure. So Firewall Premium, beyond the standard traffic filtering capabilities and threat intelligence that the standard firewall offered and still offers today, Premium kind of takes it up a notch and pushes Azure Firewall into next-gen firewall territory. The main features that Firewall Premium has are TLS Inspection, which we're going to cover in depth today, intrusion detection and prevention, which is going to be a topic for a future webinar. I think it's next month, but it's part of this spring security community webinar series. So if you haven't signed up for the whole thing, I suggest you do so. URL filtering. So this is a consequence of being able to do TLS inspection. We're able to see the entire URL of web requests, and we're able to construct rules based on that URL. And so I'll point you in the right direction on how to configure those rules based on URLs. But for the most part, the content of today's webinar is going to be about how to just get TLS inspection turned on, because I think that's the hard part. That's the major hurdle that customers have to face when they're provisioning a premium Azure firewall. And so I want to concentrate on the hard part. And then web categories is another thing that was introduced, which this is a cool one because it applies to both Azure Firewall Standard and Premium. It's just that they're implemented just slightly differently. The web categories on Firewall Standard apply to FQDNs, fully qualified domain names, and the web categories that you can enable on Firewall Premium apply to the full URL. So web categories enable you to either use allow or deny rules based on entire categories, like we have listed here: gambling, social media, there's productivity tools, things like that. And so what I think these are really useful for is a lot of customers are using Azure Firewall in environments that aren't necessarily just the server-based environments that we usually see in Azure. Especially with pandemic and a lot of people needing remote connectivity, we see a lot of virtual desktop implementations with either Windows Virtual Desktop or other implementations, and you need user traffic to be filtered by some device. Firewall, in this case, is able to handle that a lot better now because of web categories. Usually in a user environment, you want to allow most web traffic and just deny the things that you do not need. In a server environment, it's it's more of an allow list approach where servers don't need broad web access, and you can just allow each thing that you do need. So it's web categories make it a lot easier to administer traffic filtering at scale. Okay, so that is the quick overview of what Firewall Premium is. Again, there's a lot of written in our docs, blogs, etc. about Firewall Premium features, but we're going to concentrate today on TLS inspection. So to get started, let's just kind of review quickly what TLS is. Transport layer security. It's the newer evolution of what used to be called SSL, secure socket layer. I'm not going to go through every single step of how a TLS connection works, but the main takeaway here is that I've kind of put in this diagram. A firewall sits between the client and the server, and firewall can either not do much to that traffic that's going outbound from your client out to some destination web server, or it can do a lot. And in the case of TLS inspection on Azure Firewall, we're going through the scenario of firewall actually doing something to that traffic. When you don't, one of the things I want to point out on this slide really quick, and again, I'm not going to go through every single step, but while before the client and the server establish a secure channel to communicate over, which is kind of the essence of what TLS does. It creates an encrypted communication channel for the client and the server to communicate privately. When the client is first introducing itself to the server, it sends what's called a client hello message. And that client hello includes a piece of text known as the server name identification, or SNI extension. And this is one field that is, at least in TLS versions up to 1.2, this field is sent in clear text. And what that field contains is the domain name of the server, so the FQDN of the server that it's trying to contact. So this is how TLS traffic is filtered with Azure Firewall Standard, or for connections that you're not going to terminate. So we can still see the entire FQDN of the server that we're trying to access, but we can't see anything beyond that. Once that secure channel is created and the client and the server start communicating privately, all the packets that flow across a device in the middle are going to be encrypted. So all that application data, whatever is in the body of your web requests, even the full URL, and basically every other header is all going to be encrypted. It's just going to be gibberish to whatever devices sit in between that client and the server. And so that sets the stage for why we're doing TLS inspection. Because when you don't inspect TLS connections, again, we're depicting firewall just sitting between client and the server, and the line between the client and the server in this case is unbroken. And so what happens is the traffic, you can route it through firewall just the same way as you would any other traffic within Azure. And so it will go through firewall. We talked about that SNI extension. Application rules are the rule type in Azure Firewall policies, which I'll show you in the portal a little bit later. Application rules filter traffic based on the FQDN. But everything else is going to be encrypted. And so in this configuration, when you're just sending traffic through firewall, you can still do good things for security. You can still restrict which sites are allowable to your clients within your Azure environment. You can say you can go to, let's say, bing.com and not google.com. But you're not going to see anything beyond that FQDN in that web request. And so on Azure Firewall Standard, you have the ability to turn on threat intel, which if you're going to a known malicious FQDN, suppose it's a known command and control server, we can block that traffic. But we don't know what's in the request. And so we're only blocking it based on reputation. We're not doing it based on whether the payload is actually malicious. And this is why you might want to start terminating TLS. So why would you want to inspect TLS? We can use, first off, you could, instead of those application rules just looking at the FQDN of that outbound request, now application rules are able to see the entire destination URL. And so you're able to make a much more granular decision on what you can access. And then once you have decrypted traffic, because this is what TLS inspection does. I mean, I'll be clear about it for those that aren't familiar with the concept of TLS termination. And I'm using the words termination and inspection interchangeably here. So when you terminate TLS, you're able to see the entire payload. We're able to decrypt that traffic and see what's inside. And so when you do that, now you're able to actually see much more than just that, that quick server name identification. You can see what's in every piece of that packet. And so that enables us to do a lot of things. First off, I mentioned using the full URL in our application rules. That's just one piece. IDPS, so intrusion detection and prevention, is much more effective once you are actually decrypting that traffic, because it can see everything instead of having to make a decision, whether traffic is malicious or not based on just the pieces that are not encrypted by TLS, which is not much. Now IDPS can look at everything and make a decision on whether this is malicious traffic and knock that traffic down if it is. And then, the third bullet point I put on this slide is, it's going to unlock a lot more features for us to be able to introduce in the future. So again, the current offering of Firewall Premium is just doing, it's getting us up to that point where we will start to be able to do more. Today, yes, we can terminate TLS traffic. We can use the URL for traffic filtering. We can use IDPS matching against the entire request now that it's decrypted. But in the future, there's plenty more that we can do with it. A lot more inspection capabilities are now unlocked, and so keep looking at these types of presentations from us to let you know when more and more features get added on. In the graphics here, just to explain really quick, you can see on the bottom left, this is just a quick snippet of a log analytics query result of some traffic that has gone through Azure Firewall Premium with TLS Inspection enabled. And so what we're able to see is the entire URL, and then what rules affected that. So this is, I know this is not, mind-blowingly impressive or anything, but it is a lot more visibility than you would have gotten without TLS termination. So we would have been able to see, oh yeah, they went to the hostname bing.com, but we can't see where they're going beyond that. And of course, this is an innocuous one, but there are other web requests that once you see the full URL, you can see, oh, that is, that is potentially a malicious web request, and we want to investigate. So TLS inspection, it might be a good idea if you want to empower your security team. Again, security teams live off of good data, and this is, it's debatable whether every single request is going to be good data, but you can aggregate those and turn it into something that's compelling. So now, getting to, we've talked about what TLS inspection is, what happens when you don't do it, what happens when you do it. This is how Azure Firewall is going to use the certificates that we get it, and we'll talk about certificate generation and management once we get through this short section right here. This diagram is directly from the Microsoft documentation. So this is showing, instead of that one straight line straight from client to server with firewall just kind of sitting in between and not doing much, now we see firewall starting to take an active role in those web requests. And this is how we generate that good data, and how we are able to look inside those web requests to see everything that's going on. So instead of that web traffic going straight from client to server, the web connection first, when an end user says, I want to go to, in this case, website.com, the connection is going to hit firewall. Firewall is actually going to impersonate the website that is being requested on behalf of the user. And so the firewall will terminate the connection. And so the private channel is now interrupted. This is actually Azure Firewall, if you want to look at it this way, performing a man in the middle upon this web traffic in order to see what is inside, because the only way to see what's in encrypted traffic is to terminate the connection so that you are the recipient of that encrypted channel. And so basically you have two encrypted channels being created, one between the end user and the firewall, one between the firewall and the website. And what happens in the middle is that firewall, instead of handing back the TLS, the certificates from the website itself, it will generate a new web certificate based on what the client requested. It's going to create a new certificate and sign it with the certificate that we give it, and give that back to the end user. And that way the end user thinks it's communicating with the end website, when in fact there is a man in the middle there, which is, in this case, it's a benevolent man in the middle. It's your security team performing inspection to make sure that everything is okay. So how this is actually done is that the certificate that we give Azure Firewall is actually stored in an Azure Key Vault. It needs the private key, which I'll show you a little bit later. And then again, Firewall is going to use that certificate to sign every certificate that it presents back to the clients on the network, in order to make that channel still secure. It's still encrypted between the end user and firewall, and between firewall and the server. It's just Firewall gets to see what's happening. So hopefully that explains Firewall's role in a web request when you have it configured that way. So one thing I didn't mention earlier is the directionality of the termination. So we're talking about termination and TLS inspection on outbound traffic primarily, but we can also do it on east-west traffic, which is traffic originating from one part of your Azure virtual networks to another, or even in a hybrid network. Suppose it's a client on-prem, when those are possible again, making a request out to a private Azure resource, we can terminate there as well. And so what we don't do on Azure Firewall is terminate inbound connections. And the reason that we don't do that is that we already have 2 services within Azure that terminate TLS connections inbound for websites by default. This is just what they do. Azure Application Gateway and Front Door, especially paired with WAF, are the correct choice for wanting to inspect inbound TLS connections. Firewall can be put into the mix by putting it behind an application gateway. So basically between the app gateway and the backend servers that the requests are going to end up at. You can set up some routing that makes it so that app gateway passes traffic from inbound traffic through firewall on the way to hit the backend servers. And so you technically can have a scenario where you terminate and inspect with WAF on application gateway, then pass back to Azure Firewall. And you can have it encrypted again and then decrypt again at Azure Firewall and then send it back to your backends. It's not an ideal scenario. It's kind of cumbersome, but it can work in environments where it's required. But think about firewall, app gateway, all these different tools that kind of add up to create a secure network in Azure as all modular components. So a lot of customers that I talk to that say that's great that firewall can terminate outbound and east-west, but what about inbound? What do we do then? Those tend to be the customers that are used to having one appliance that does everything. They have an on-prem appliance that just does all these things, or they have a virtual version of that in one of their cloud providers. The way that we've kind of created these services is to each do the job that they're best at. And so rather than provision one giant appliance that does everything, the cloud is supposed to be pay for what you use and don't pay for what you don't. And so if you need inbound inspection for web applications, you use a device that's purpose built for that use. And if you need something that is for outbound and east-west and central traffic filtering for everything else, then you use Azure Firewall for that. So that's the quick explanation of why one direction and not the other. Okay. So going into how do we get these certificates that Azure Firewall is going to use to inspect requests? So there's 2 main ways that you can create a certificate for Azure Firewall to use. One is to create a self-signed certificate, and you can do that with using OpenSSL on any Windows or Linux machine. I think Mac does it as well. But you can create a certificate anywhere. You can sign it from one machine. The problem is that whatever method that you use to generate a certificate, you have to make sure that your clients trust it. We'll get to why in a second. The other major method that customers use to generate certificates for Azure Firewall to use is using Azure Active Directory certificate services. So if you have an existing PKI infrastructure, whether it's just on-prem or whether you've got that extended out into Azure via some hybrid arrangement, you can use your existing PKI to issue certificates. And PKI does have some advantages because in a domain environment, those certificates are automatically trusted. And one thing I'll mention as well, the certificate type that we need that Azure Firewall is going to use is actually a subordinate CA certificate. So essentially, we're generating a certificate as though we're going to be standing up a subordinate or intermediate CA certificate authority that is going to be signing requests, signing other certificates on behalf of the root CA that issued it. And so basically, you can think about Firewall as that. It is fulfilling the role of a subordinate certificate authority and issuing certificates on behalf of the root CA that you've used to sign it. So for that reason, you see only private CAs listed here as the eligible types of certificates that you can use. You can't use a public CA like you would for a web server because we're going to be signing other web requests, other server certificates on behalf of that CA. And so no public CA is going to issue a certificate for you to then reuse to sign other things. You know, that's a recipe for disaster. So you have to use some sort of private CA, whether it's your own, you know, CA that you've created just with an open SSL command line, or whether it's something that is an existing CA infrastructure, part of maybe an ADCS PKI. Okay, so I talked about certificate trusts, and this is a big important one because it's really easy. You know, again, I mentioned just a quick. It's 2 lines of commands that you can use to generate a CA certificate, a self-signed certificate. But the problem with a self-signed certificate is that nobody trusts it except for the machine that signed it in the first place. You know, I can stand up a CA on my Windows desktop right now, but it doesn't do me any good if nobody trusts that certificate. And the reason trust is important is that when you're trying to, when you do a web request against a certificate, a server that is showing you a certificate that you don't know, that you don't trust the root CA that signed it, then you start getting errors. Granted, you can clear these errors, but if you're in a user environment, nobody wants to see this "your connection isn't private" message for whatever you're trying to request. More importantly, if you're in a server environment, chances are, and I put in a quick screenshot of you know, a Linux server just trying to do a quick wget request. If you're in a server environment, chances are you're doing a lot of whatever web requests you're making. It's not just, you know, a user browsing to Bing or whatever to do a web search. It's your traffic is probably part of a line of business application that's making some request out to the internet, and you know, it needs to happen quickly. If the client doesn't trust the certificate that's being handed to it by firewall, and you can see down here in the very bottom right, you can see that the certificate's been issued by Azure Firewall Manager CA. So it's not been issued by the CA that you would have expected from Bing.com, and that's why this client is saying, whoa, this is somebody's man in the middle, and they're correct. You are being man in the middle, but again, a benevolent man in the middle. So knowing that we can configure firewall to intercept TLS connections pretty easily, and we can self-sign a cert, and we can get it you know, into firewall and configure firewall to use it correctly. But if we don't establish trust throughout our environment, then we're in trouble, because nothing's going to, I mean, things will work, but you have to make extra clicks. You have to do extra things. It's not going to be seamless. What we want is this to be seamless. We want it to be transparent to the users and to the servers that are making these web requests. So there's a few different ways that we can establish this trust. Starting off, you can just do it manually. I mean, you know, if you've got 1 or 2 machines in a test environment, this is easy enough. If you've got the exported, you know, public cert from your root CA on a Windows box, you just right-click on the thing and you say install certificate. Done. Now you trust it. Similarly with Linux, you can just you run a couple of commands really quickly, and then that one client trusts that cert. But in cloud environments, we're not dealing with 1 or 2 clients. This is fine for a test environment, but how do we do this at scale? This is the important part, and this is I think a very important thing for any organization to figure out and have a strategy for, if you're going to implement certificate or TLS inspection with Azure Firewall, or really anything else. So there's a few different methods that you can do. One, as I mentioned before, PKI is a great option if you already have a hybrid PKI environment. So if you've got domain joined machines in Azure, and the CA is either in Azure or it's on-prem and you're hybrid, then you can provision your certificate from that enterprise CA, and all of your domain joined clients, and I'm saying specifically an enterprise CA, all of your domain joined clients are going to trust that enterprise CA and everything it signs and everything that signs on behalf of it implicitly. So you don't have to do any extra steps. If you're already in a domain environment, you can just create this, and I've got it boxed out here. You use this specific certificate template, which is the sub CA authority. And there's a couple of other requirements that I've marked here as well. You need a key size of 4096 or longer, and you need to have the keys as exportable, because Firewall needs that private key in order to actually use that certificate to sign its own. So this is probably the easiest way to do it. But again, its prerequisite is that you already have a certificate authority and a PKI already set up in a domain environment. This is less easy if you've got, you know, a mixed environment with Linux machines. But if your primary use case is domain joined Windows machines, this is super simple and it's highly recommended. So if you're not using a domain, what can you do? You have other options. One is to use Intune or Microsoft Endpoint Manager. With Intune, you can use configuration profiles, and there's a built-in configuration profile in Intune which will allow you to install trusted certificates to your endpoints. And this is great. Again, and this is another one of those methods that, sorry Linux, you know, you're kind of left off on this one. But for non-domain joined Windows machines, if you've got a bunch of workgroup machines but you manage them with Intune to push out other configuration policies, configuration profiles in Intune, this can just be added to that list and you can easily manage certificate trust across your environment. This one is great because you can still, even if you don't use, you know, even if you don't have a proper certificate authority in your environment, you can just, it doesn't matter what certificate you use here, it can be a self-signed certificate. You can just spin up some machine, use a self-signed certificate, protect the key properly, and then you can send out that certificate for all of your clients to trust via Intune. So it doesn't matter how you provision the certificate. In this case, it just matters how you manage it. The previous example with PKI is, again, it's easy because it's both provisioning and long-term certificate management, rotation. It's all kind of built in. With Intune, you will have to replace that certificate periodically, and same thing with any of the other methods that we'll get to here. So just pros and cons of any of these setups, but you know, just putting all the information out there. The next method here is to use custom images. This is, again, this works with any VM. This is Windows, Linux, whatever. It's OS agnostic. But basically the principle here is that you just bake in the certificate into your custom images, share them out via a shared image gallery, and then any VM that you provision with those shared images automatically has that certificate installed and it's trusted. So this is, again, pros and cons to every approach. This works great in environments where your servers are disposable. They're spun up, spun down all the time. It doesn't really, you know, they're I'll refer to them. It's better when your servers are cattle and not pets. If your servers tend to be around a long time and you can't rebuild them, you know, anytime, then you have to figure out how to install certificates live instead of installing certificates via rebuilding those machines. But this is a viable option for environments that are a bit more cloud native, because the VMs are looked at as they're just kind of a disposable commodity. You destroy them, create them all the time. So if you have to rotate the certificate in the future, you can easily do so without having to worry about lost configuration. Okay, so I think I left us a good amount of time to go into the demo. Again, you know, the first part of the presentation was all kind of concepts, and so now I will take you through the how-to and what this actually looks like in the portal. So stop me if you can't see my screen, but I'm going to proceed with the assumption that you can. I'm going to go into, great, thanks, Fallon. All right, so the first thing I'll do, this environment that I have here is, it's a pretty simple hub and spoke environment. It's actually a single hub and a single spoke. All my VMs live in the spoke network. The VNets are peered together, and there's routes in place that forward all web traffic from my spoke network VMs out to the internet via Azure Firewall. And it's about the simplest environment that you can set up to test all this stuff out. But I do have a number of virtual machines in this environment. I've got an example of each of the concepts that I put in the slides. I've got domain joined machines and Intune joined machines and etc. So I want to just show you the Firewall Premium policy that we're going to be working from, and that kind of enables all these features. So you can see in the firewall policy, there are a number of settings here. We've got all the different rules that we can have, the DNAT rules, the application rules, the network rules, DNS settings, which here I actually have my DNS traffic all filtered through the firewall and pointing to a custom DNS server, which is actually my domain controller. And in this small test environment happens to be my certificate authority. So this is, I want to kind of point out this because I think this is an underrated feature of firewall, and this is firewall standard and premium. You can use DNS proxy to forward all DNS traffic through Azure Firewall, because by default, if your VMs in Azure are just using kind of the default VNet settings, they're going to Azure DNS for their resolution, but they're going straight out. Even if you have all your traffic routed through Azure Firewall, DNS requests go straight to Azure DNS, and that's a problem, not necessarily a problem, but it's a gap for security teams in terms of visibility, because Azure DNS doesn't log requests, individual requests that come from your VMs. If you enable Azure Firewall as a DNS proxy, which is down here, whether or not you're using a custom DNS or if you're using Azure DNS as the default, if you enable DNS proxy and then you point your VNet settings for DNS to Azure Firewall, then all those requests go through Firewall and get logged. And so I think that's a huge advantage. It's not on topic right now, so sorry about the digression, but I think it's a super important topic. And there's a blog post that one of my colleagues wrote about this that's on our tech community blog. So maybe somebody can throw that one in the chat. Okay, so on to the topic at hand. So this is where you configure TLS inspection. Once you have all your traffic forwarded to Firewall, and again, you can see a previous webinar to figure out how to set up an environment for Firewall, including routing and peering and all those things. Once you have everything set up and traffic is going through Firewall, if you want TLS inspection turned on, it is as simple as these 3-4 options here. You just click enabled. You figure out you have to have a managed identity, which it's going to use to request the certificate and key from the key vault. You pick the key vault that you want, and you pick the certificate that you want. And that's all in this. This is the key vault that we're using here. We can see that we've got this certificate has been imported here. And back to our firewall policy. This is all there is to it. Once you have the certificate in the key vault and a managed identity for the firewall to use to access that key vault, then you're all set and ready to go. What I will show you is one more thing in the firewall policy that you can do once you actually have this created. So if I add a rule, and let's see, I'm going to go with my application firewall, this one. So what I can do, you can see down here, TLS inspection is just a checkbox. So this is, you actually tell Firewall which traffic to TLS inspect. And so this deals with things, I'm sure there's probably, I'm not monitoring the chat, but I'm sure somebody probably asked about how do you deal with cert pinning, and just generally services and websites that do not like to be man in the middle by a firewall. So you set up the ability to terminate TLS on a connection by connection basis. So here in the rules that I've got generated so far as my examples, this is a super permissive firewall policy, and I don't recommend this obviously for production, but I'm basically just allowing all traffic and I'm inspecting some. So there's one rule that allows, star as a destination. So all 443 and 80 traffic from my internal network gets allowed outbound. And then I have another one that's a little bit lower priority, lower number of priority, but higher priority if you want to think about it that way. That is going to use the web category of search engines, and it does have TLS inspection enabled. And so what we'll see, and I'll show you this on the VMs, is that when we send general web traffic out the firewall, we're going to allow it. If we send web search engine web traffic out the firewall, we're going to terminate the traffic. We're going to see what's inside, and we're going to and if we were to create some more advanced logic in some of these rules, like denying certain URLs and allowing other URLs on the same FQDN, then we could see some of what you can do. And again, terminating this traffic means that IDPS here is now more empowered to see all that traffic. So that's a major point here. And I won't go much into IDPS right now. I'm just going to show you that it is an option that you can select. Alert and deny is best case scenario. But if you don't have application rules that are inspecting some of your traffic, then IDPS is not going to, not all the rules are going to be as powerful as they would be, because they're going to be looking at encrypted traffic instead of decrypted traffic. So let me move on to the VMs here. So I do have, this is, and I'm accessing all of these VMs via Azure Bastion. And so I don't even have to have an RDP client or anything like that. Just accessing them right in the browser. So really quickly, I'll show you how to request a certificate if you are in a PKI environment. So what we can do is, if you do an advanced certificate request, and pay no attention to my certificate error here. I know I'm doing a presentation on certificates and I don't have my own figured out, but just pretend you didn't see that. So once we get into this certificate request form, you can see there's a number of certificate templates that you can use, but this is the one that you want. You want the subordinate CA certificate, which is going to be the one that is going to allow us to sign on behalf of this root CA. And then we want to extend our key length to 4096, and we definitely need to make these keys exportable. And once you go through this wizard, you'll be able to export that certificate. And when you export it, you need to save the private key along with it, because again, we need the private key to be able to sign requests. And that is the certificate that you would throw into Key Vault. And if we have time at the end of this, I can show you the upload process to Key Vault. It's pretty simple. I need a demo, but I can do it. So let me show you really quickly what it looks like. So this is my first VM. This is a Windows 10 machine. This is not managed by anything. It doesn't have the cert trusted at all. And right here, you can see I've navigated to a website. And remember our two application rules, the one that was for search engines that did TLS inspect, and the one that was for everything else that does not TLS inspect. And so what we can see here, if we look at, it says, okay, we've got a valid cert, and this cert, we can see this is New York Times. And it's issued by a public CA that is just automatically trusted. If we look at the certification path, this is a well-known public CA that is just trusted by default on most clients, Windows, Linux, whatever. Usually the major public CAs are already trusted. It's the private CAs and that sort of thing that you have to establish trust with. And so what happens if we go to, let's do bing.com. So if I go to Bing, that's a search engine. And so now I'm getting that error. So it's saying like certificate authority invalid. It can give me this encoded certificate, or I can just take a look up here, take a look at that certificate. And you can see this certificate, rather than being issued by a well-known public CA, this has been issued by Azure Firewall Manager CA, because we've done that inspection. You can see the certificate chain. It's been signed up here, and we can see all the way up to the intermediate CA, that the certificate that we exported in the first place. So this machine doesn't like this because it doesn't trust that. We can tell it, go to advanced, and in certain settings configurations, I can say I want to continue anyway. And then I can show you too, like if we were just to do, we can do it with PowerShell as well, and we can see here that we also don't trust the connection that comes from here. And you've got to put in some command line arguments in order to ignore the cert trust issue. And it's problematic. It is not a seamless experience. You could still continue onto these websites, but in a production environment, you want things to be a bit cleaner. So how do we do that? In our Windows 10 domain, this is another Windows 10 machine. This one happens to be domain joined. You can see down here, domain fabricam.local. And this is, so it's joined to the domain that is controlled by this machine up here. And again, this is a domain controller. It's a certificate. It's a CA, an enterprise CA, which is linked to the domain. And so this machine automatically trusts this certificate. So if we go into our certificates, snap in, and we look at our trusted root CAs, we can see, in addition to all of these, and I think this was the initial CA that issued that New York Times cert. Now we have the Fabricam CA, and that. So now we can see, here's my Bing request, and we can see happens just fine. There's no error. If I go into here, my certificate's valid, and I hover over it, it's showing it is issued by Firewall Manager CA. But in this case, I trust it. I can look at the certificate path. The Bing.com certificate was issued by Firewall Manager CA, which was issued by my intermediate CA cert, and which rolls up to the Fabricam root CA. So in this domain environment, since I requested the cert from my enterprise CA, and all of my domain join clients trust it, I didn't have to do anything else to this machine. It's domain join, it trusts it, no problem. So now in a non-domain join environment, so if I go over to my Intune, my Microsoft Endpoint Manager, and I go into my devices, I can go down to configuration profiles, and I've already created a couple of configuration profiles, but you can see here, if I select platform, and we'll call it Windows 10, I have, actually it's Windows 8.1 and later, there's a trusted certificate profile that is already created by default. So all you have to do is create this one, and I can next through this stuff and create another profile. But in this case, I have one already created that I can show you. This one is a trusted certificate. You can see it's profile type trusted certificate. It's assigned to this one machine. It's compliant, so it means I've actually installed that trusted certificate. And if I look at that machine, I can see basically the same thing as I saw on my domain join machine, which is, instead of being domain joined, my colleague Ashish managed this with, enrolled this in Intune, and so it's managed there. But it is, in fact, it's a workgroup machine, not domain joined, so it doesn't have that cert by default. But in our trusted root CAs, we can see, again, that Fabricam CA is trusted. And so the behavior, I won't demo it again, but the behavior will be the same because it's actually trusted. So a number of different ways, and I didn't show the image baking in a certificate to an image because that one's a bit more involved, requires a lot of machine rebuilds and things like that. But you can see there's a number of ways that you can achieve the end goal, which is seamless operation. And once we have that, now we can start subjecting this traffic to the more inspection. We can run all of our IDPS signatures against it. We can filter traffic based on its full URL path. And then again, part of the great advantage of this is just unlocking future things that we may release. I mean, not committing to anything that's on that's actually like planned for any release, but there are other firewalls out there that have, you know, user and application awareness and DLP and things like that, and those are all things that have been requested of us. And now that we can terminate TLS and we can see the whole packet, all those things become possibilities. You know, again, stay tuned to our blogs and announcements and things like that, so that we can tell you officially when we commit to any of those things. But just to give you an idea of the extra things that are possible once you get a service like Azure Firewall Premium into your environment with the ability to see TLS. So I'll stop my demo there. I will go back to the slide deck and bring it to this very last slide. And that's everything I have today. I know I think I only left us about 2 or 3 minutes for any questions that maybe didn't get addressed in the chat, but I'll open it up there for my colleagues to tell me if there's any questions that we need answered now. But do please click on all these links. This deck will be uploaded along with the recording. But take a look at our blog, our GitHub, and if you like the GitHub samples that we have, and you have your own, please contribute. We need more. So any help out there that we've provided, you know, do your best to throw something out there and help out the community. Any questions that I can answer from my team?
I am taking a look here. It looks like we have everything covered up until now.
Good. You all are just too good at answering questions.
Okay, great. Well, thank you, Anthony, for an excellent presentation. And of course, thank you to the rest of the team who helped answering all these questions. I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is by visiting our landing page at aka.ms/security-community. And while you're there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bit-sized product videos, ninja trainings, recordings of the past webinars, the GitHub communities, and more. We'd love to hear your feedback on how we can improve on these webinars. So please take a minute by submitting your webinar feedback at aka.ms/security webinar feedback. And in case we missed to answer your question, or in fact, if you have additional questions, you can visit us on our Azure Network Security forum at aka.ms/Azure Network Security community. I want to thank all of you for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.